Okay, so today we're going to talk about elements on the periodic table. And let me go ahead and show you this. And most of you guys know this already, but I do think it's always good to kind of review this item with you. So the chemical symbol is always going to be a 1 or 2 letter abbreviation. The atomic number is the smaller of the two numbers and always equates to the proton number. And then the element name that's on the tile will always be there too. And then the atomic mass is the number of protons and neutrons that are combined together. So again, when you look at this, we have atomic number equals the proton number, atomic mass is proton number and neutron number. In a neutral atom, the number of protons equals the number of electrons. Okay, I have this chart here. And what you guys want to do is actually fill this chart in for these individual atoms. And do not use the atomic mass from the periodic table, because we're just pulling out one particular atom. And that atom may have different properties or different number of protons, neutrons, and electrons. Well, just different number of neutrons and electrons than what's on the periodic table. So go ahead and pause the video and try to fill this out. And then I'll have the answers on the next slide. I'll go through some of these, and then I'll take questions on this at a future date. Okay, so go ahead and pause this and try to fill this out from this point. Answers will be on the next slide. Okay, so here are the answers. I'm going to go through the first two in detail. So I have over here, the symbol is 29/14. So I know the name, because this is cobalt-58, must be silicon-29. I know that the atomic number of silicon is 14, and I know that the mass number is 29. I gave you that the charge is 0, so therefore the protons must equal the number of electrons. So the proton number is going to be 14, the electron number is going to be 14, and then 29 minus 14 will give me a neutron number of 15 for that one. Okay? Let's do number 2. I have cobalt-58. Cobalt has an atomic number of 27. So when I do the symbol, it'll be 58/27 will be CO. The mass number will be 58. Since my charge is a +2, that indicates that there are 2 more protons than there are electrons. So the proton number is going to be 27. The electron number is going to be 25. And then 58 minus 27 gives me a neutron number of 31. Hopefully from those two, the other 3 will make sense. If you guys have questions over those, I will take that in class at a later date, as I stated. So let's talk about atomic mass. Why is atomic mass not an even number? Well, it comes down to we have these things called isotopes. And so for the atoms, there's actually more than one type of atom you can have, and those are different isotopes. So chlorine actually has 2 isotopes, chlorine-35 and chlorine-37. And so you have to know details about this to get the atomic mass, because the atomic mass you actually see on the periodic table is the average atomic mass. So chlorine-35 actually has a mass of 34.97. The abundance of chlorine-35 in nature is about 75%. For chlorine-37, the mass is actually 36.97, and then the abundance in nature is about 24%. So you're going to do just basic mathematics to get the overall atomic mass, and here's how that looks. We're going to take the mass of chlorine-35, which is 34.97. Then we're going to multiply it by that relative abundance as a decimal instead of a percent. That'll get us 26.49 AMUs. Chlorine-37 has a mass of 36.97. The relative abundance, when you write it, has a decimal, is 0.2424. That'll be 8.96. And when you add those two together, you're going to get 35.45 AMUs for that. So here's the other thing you guys can do. You can identify an element from this. So if you look at the mass of this element between 63 and 65, And you can see that we have about 70 here and about 30 here, that the mass is going to be closer to 63. So probably somewhere between 63 and 64. And when you look at the periodic table for an element that has a mass around 63 or 64, that element's actually going to be copper. And this is the data for copper from this graph. So what will happen is the percent of copper, which we got from the graph, is 69.09. So I'll put that into a decimal. And then that's 63. So we take that times this to get this AMU. The 30.91 came from the other bar on that graph. Times 65 will be 20.09. And then when you add those together, you're going to get 63.62 AMU for copper for the average atomic mass. Now let's try a potential question here. Chromium has 4 isotopes. It has 50, 52, 53, and 54. You can see the percentage of these isotopes here. And what is the average atomic mass of chromium? Now, you can figure this out by guessing. That would be fine. I think you can all agree. The biggest item is going to be 52, and it's going to be a little bit heavier than 52, so it'll probably be C for this. But again, it's good to be able to work out the work for that and to make that happen. And so to get the work to get C is on this slide here. Oh, let me just back up. So I want to make sure we're clear that you may not have to do the calculation, but I want to show you the calculation in case you need it. For this one here, because 52 has 84%, and then we have 11% that's above 52 and only 4% that's below, we know that it's going to be just slightly higher than 52, and the only one that fits this is C. So again, even without doing the mathematics, I can determine by estimating that it's going to be C. Now here's the work to make it C. So 50 times that will get us this. 52 times this percent as a decimal gives us this. 53 times this as a decimal gives us this. 54 times this as a decimal gives us this. When we add all those together, we get 52.05 for that to happen. I have one last example for you guys to work on. We have this mass here. Mass 12 is a relative abundance of 98.90. Mass 13 is a relative abundance of 1.10. Go ahead and pause the video, work out the mathematics, and then the answer is on the next slide. Okay, so what's going to happen is 12 times 0.9890 will give us 11.868. 13 times 0.0110 will give us 0.143, and that'll get us an atomic mass unit of 12.01. Okay, that is it for this topic. We'll spend some time reviewing this and go from there.